Hello. So in the last video that we were discussing about character recognition algorithm using correlation. The last video was based on was a project code demonstration, but a major portion of the project code demonstration was stressed upon how the main function is designed, how the main algorithm has been implemented in our project, and all the functions called and basic flow of our code, and also the training of the alphabets and the letters, the English alphabets and the letters. So in this part of the video, this will be a relatively shorter video, as we will be showing you several examples, and we will be stressing upon certain facts and certain important steps that help us analyze our solution to the problem. So for example, um, we have these four images, scanned images. Three of them are typed with different colors. One is handwritten. So we will use each of them one after another and see how the simulations are varying with respect to time and with respect to the accuracy attained. So this is the test IM4, which is basically this image. So you see that the sizes of the text are different somewhere. Some are uppercase and some are lowercase. Some are in different colors. So what we thought to achieve is there would be thresholding, there would be binarization because of that thresholding, and there would be an aspect ratio adjustment to match the size of the letters and the numbers in the library. So we should the size of the font and the type and the colors should be immaterial in our project. So let us run this file. So you can see that in this histogram, this is the grayscale conversion of the histogram. For example, that image is first converted to grayscale, over here, and then we draw a histogram of the grayscale image. So this is the histogram of the grayscale image. You see these small peaks, which are the black intensity pixel indexes, and these are the pixels which are having the lighter pixel intensity or the lower pixel intensity towards white. So suppose if you want to separate out pixel clusters of less than say 5, so you can see there is a binary thresholding. This is the output that we get. There are a lot of problems. 2-3 letters are recognized in a different manner, but you can see that the image is converted to a binary image. You can see some of the letters are smeared to some extent because of, and because of this breakage and smear, there are problems in our recognition algorithm, but the main correlation function does a proper thing. Also you can see the time elapsed. It is a huge time elapsed because as you can see, there were a lot of changes in the font type. There were a lot of changes in the font type. There were 3 line breaks, and there was a color difference. So because of that, in the code we have implemented also a timer. The timer starts just after we convert the colored image to a grayscale image, and we put a timestamp just after. Here is the timestamp for just showing that specific instance. So at this point is where one line decoding has been done. So one line, each of the letters in one line has been decoded. So after every line, the timestamp should be printed on the main MATLAB screen. So this is there are 3 lines. So this first line, the simulation time is taken is this one, second line is this one, third line is this one, and the fourth line is 46.49 seconds. This is nothing but, if you can go to the code, this fourth line is from this to this duration, which should be obviously less than 1 second, because it does nothing but to open up the text file. So that is the reason it shows 4 time instances. So for example, let's use some other image. Let's use image 3. right? Image 3 is this one. So this is again a different colored image. The fonts are same, but there is a these are in uppercase and this is in lower. This is in uppercase and this is in lowercase. So let us run, and again let us remove. Let us comment in, because we don't want to clutter our MATLAB with so many windows. So let us comment here and let us comment here, so that we don't want to see each letter popping out one after another. So if we run this, so you can see, since the image was having a lot of bright pixels, so the bright pixels are showing up in the later part of the histogram, and this is the darker intensity pixels. So theoretically the threshold should be somewhere at 0.75 or something, correct? So let us give a pixel value of say 15. So you see that, so there are 1 2 3 4 line breaks. So each line break has got a timestamp. So it takes 31 seconds for the first time, because obviously it does all the thresholding, all the operations for the entire image first, morphological opening of the entire image first, and then it tries to extract each line, each line from the entire paragraph. So the first time it takes a long time, and these are the time taken by the algorithm for each line detection. Right. So if we see the threshold value, so as we expected, it should be something around 0.75, which was on the 3/4 part of the histogram, which was correct. So let us take another example. Let's take an image which is not black, which is not a colored image, but which is completely black, but it is handwritten. So the image that we are considering is this one. It is handwritten by me and it is completely black. So we might be seeing a lesser amount of simulation time. Let's see what happens. 15. Yes, see, because it doesn't have to convert to grayscale, because it is already in pretty much in black and white. And simulation is also, I mean, it is just one letter problem, but the entire idea is same. The detection is correct, and it has got two lines. So the first two lines are the lines for each line, are the time taken by the each line detection, and you see the threshold, it is 0.56, because it is either black and white, and it is pretty much a black and white image. So the threshold should be something around the center point of the entire histogram. So that it is. Also, if you want to see each letter as we expressed in the last video, we can comment out here, run it, 15. So we see each line coming up by itself. Correct. So when we do an each line popping up of the windows, it takes a lot of amount of time, because that is the idea. It takes I have manually put up a pause of 2 seconds, so the 2 seconds is added to the main algorithm time. And the threshold is again the same, because we are using the same image over and over again in this specific example. So pretty much this is how we go about solving our problem of character recognition. The part that we use for recognizing the letters here is correlation to two-dimensional correlation coefficient comparing, but we can use other algorithms like pattern feature extraction, and artificial neural network, convolution neural network. But the main idea is to have some sort of correlation, either based on some feature or either a correlation of the entire word. So since we are using English letters and English alphabet, and the and we are focusing on optical character recognition, which was focused on typewritten font. So we are good enough with using the correlation 2 function. So thank you very much.